Welcome to the Stormsurf video El Nino forecast for the week starting Sunday, January 25th. So this is the second forecast. Second part, we split our forecast into two pieces, the surf forecast and the El Nino MJO forecast. This is the El Nino and MJO forecast. All right, currently looking at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO, and as we previously have discussed, the MJO, when in the active phase, supports storm development in the North Pacific Ocean during winter months. We are currently on a very good run of negative numbers. Notice this. Minus 29, minus 43, and it just stays in the minus 30 range. It has been for, 10 days now? Very good sign. Certainly suggestive of the active phase of the MJO and maybe something more. Probably not El Nino. We're way past the point in time in the year where if an El Nino were to form, it would have done it by now. We're looking at energy to support perhaps an El Nino later in 2015, perhaps the fall of 2015. This is a good start. Westerly wind burst is what we suspect. Certainly negative numbers. The 30-day running average down to minus 11.95. The 90-day running average minus 8.88. This suggests that certainly the 30-day running average, we're in the active phase of the MJO. And if El Nino were to go or be developing, certainly we would want to see numbers south of this, more negative, but we're going in the right direction. Next, we look at surface wind anomalies, that is, differences from normal in wind speed and wind direction for this time of year. You can't see it very well, but there is strong, large arrows here pointing to the west, suggestive of a westerly wind burst in flight at 160 east, working its way to the dateline. Oh, let's get referenced here. Philippines, Australia. It's kind of hard to tell. The maps are not, or the land masses are not well defined in these charts. And then here's Hawaii. And so the westerly winds, and we're only interested right on the equator here. Notice westerly winds continue, slight, but the whole way almost into the Galapagos, indicative of a westerly wind burst, the active phase of the MJO. All this is good news. Next, we look what's going on a week out, and the picture continues bright, if not even better. Notice, good, solid westerly anomalies forecast over a larger area. This is in the heart of the Kelvin wave generation area. That area pretty much bound from about here to about here, and just a couple degrees on either side of the equator. And if you have westerly winds here, that helps set up a Kelvin wave. Kelvin wave is a warmer than normal pool of water that tracks under the equator, erupts off the Galapagos Islands, starts warming the East Pacific, where normally there is cooler than normal waters, and that's what sets El Nino into motion, changes the global weather patterns, and makes for better odds of storm production in the North Pacific in winter months. Anyway, so good westerly winds, westerly anomalies forecast a week out in the West Pacific, not so much in the East Pacific, but that doesn't really matter. And also notice this, it looks like a typhoon developing in the West Pacific as well. So all this is good sign. Continuing down, another way to look at this, here's time. Oranges, reds are westerly wind bursts. Blues are easterly wind bursts. And then here is your position. This is the entire globe on one chart. We're interested in the area from about 120 east. This is where the start of the Pacific Ocean to about 90 west. Okay, and you notice here's westerly winds started in January on the hairy edge of the West Pacific. Here's a start of our westerly wind burst in about the 16th of January, and here was where we currently are, and the forecast projects yet more westerly winds working their way towards the dateline. This is good for Kelvin wave development. Next up, outgoing long wave radiation models. These help us identify where the MJO is. These oranges and reds are the inactive phase of the MJO. The blues are the active phase. Currently, the blues suggest less reflectivity off the ocean surface, meaning more clouds, meaning the active phase of the MJO. This is a lot of reflectivity, meaning high pressure, meaning the inactive phase. So what's currently set up, active phase over the dateline inactive phase in the Indian Ocean. The statistic model suggests the active phase is to just fade out and the inactive phase is to come in over the next 2 weeks, and that's pretty much the end of it. Now, here's the interesting thing. The dynamic model, which is a little bit more responsive to current state of the atmosphere, suggests the MJO, the active phase, is actually supposed to fade a little, but retrograde and redevelop and become reasonably strong 2 weeks out. If this were the case, we would see another bout of storm development in the North Pacific Ocean, or at least the thought would be the odds are increasing would increase for more storm development, probably focused in the West Pacific Ocean. If this could make its way east, then storms would move closer to the U.S., not so good for surf, but increases the odds for rain and snow in the Sierra. And finally, the ultra-long lead 40-day upper level model, same thing. Greens here are westerly winds or the propensity for precipitation, yellows and orange, the inactive phase, and lack of precipitation. This is new on the chart, just as of today. Notice greens building over the equator in the West Pacific Ocean, and this is pretty much like a week before what, if it shows it in the model, it takes a week for it to actually manifest down at the surface. So this says probably the active phase of the MJO continuing east into the 9th of February, which would be nice, then followed by the inactive phase, continuing through till almost the beginning of March, and then another active phase behind that. But once you start getting into March and April, the active-inactive phases have a lot less impact on the atmosphere. It's really the I'd say the September into February time frame or early March that the MJO has its largest influence. And yet one more chart, this from the TAO array, buoys on the ocean surface, actually giving you hard data rather than modeled projections. And notice this is actual wind speeds, and notice this, actual wind speeds actual wind direction out of the west over a good portion of the equatorial Pacific. And then here's the anomalies, and notice the anomalies are sitting over a pool of warmer than normal water as well. So this is a good sign, very suggestive of another Kelvin wave in flight. Also notice that we have not really warm temperatures. They're not cold, but they're just neutral temperatures over the East Pacific. This is likely the result of an upwelling phase of the Kelvin wave cycle. Nothing to be alarmed, just typically what happens when you have a couple of Kelvin waves or even one good strong Kelvin wave. Then you'll get a bit of a cool down phase, and then the next Kelvin wave will warm things up again. But notice overall temperatures are not off the chart. They're only half a degree above normal, other than this one area right here. That's certainly not El Nino at all. And here's the backed off picture. This is satellite-based surface level water temperature anomalies. Notice light warming here on the equator, and it's the equator that we care. Yes, it's nice that the water temperatures are warmer than normal in California and over in Hawaii, but in terms of affecting the jet stream, affecting the weather patterns, it's this area actually bound between 120 and 170 that they use for monitoring El Nino. Notice there's pockets of warmness here, but nothing off the charts. We're talking half a degree or so. And then a larger area here, and this pretty much supports what we saw in the previous chart. And here's yet one more chart. You can actually see over time the temperature. This is the Nino 3.4 area. That is that box that we showed you earlier between 120 west and 170, the one they use to measure and really declare whether you have El Nino or not. Notice temperatures sunk to 0 in late December and January. Now we're on the rebound a little bit, but still, these are half a degree anomalies. If you were into a real El Nino, a strong one, you'd be into a 1.5 degrees, pushing 2, and historical El Ninos that are very strong, above 2 degrees. We're nowhere near that, and there's no thought that we are going to be anytime soon. Next, let's take a look at subsurface temperature anomalies. Here's actual water temperatures. Notice the little X's here, these little things. These are actual, and here, West Pacific, East Pacific, depth, 200 meters, 300 meters. These are actual anchor lines on buoys floating on the equatorial Pacific, and the X's are the sensors actually used to get water temperatures. It's not the temperatures that matter so much, it's the anomalies that we're interested in. Notice and this, here we go, right like that. There's the date line right there. Notice a pocket of 2-degree anomalies building from the date line pushing east. This is what we think is a new Kelvin wave that's in development. Westerly winds blowing at the surface here, they actually cause warm water to fall to depth, and then that warm water makes it the whole way across the Pacific, gurgles up off the Galapagos, gets caught by trades, and then blows into the Nino 3.4 area, which is basically right in here. Okay, so the pathway is open. This cold water is not choking anything off. We have an open pathway. We have a potential Kelvin wave developing. This is good news. Here's another view of that, different model. It's showing the cooler water a little bit more pronounced, and it's showing the potentially developing Kelvin wave, not quite as defined, but this is older data from the 18th, so we're almost a week ahead of that now. We expect the next image to show the new Kelvin wave a little bit better than this one. And the same here. This is satellite-based ocean surface measurements, height variations from normal. Strip out all the waves, strip out the tides, strip out any geographic anomalies and anything else, and this is the absolute sea height variation from normal. And what you're seeing is about 0 to 5 degree anomalies. Not, where's the scale? Oh, the scale's not even here. Okay, but it's not very much. But when you have height anomalies, especially in this area, that suggests that you have warm water at depth. Warm water at depths causes the surface of the ocean to rise a little bit. Warmer water expands and it causes the surface to rise. And so you get a sense that, yes, there is some warm water building here, perhaps a new Kelvin wave. And you also see less depth here, cooler waters, the upwelling phase of the Kelvin wave. And again, this nice chart, upper ocean heat anomalies over time. February, a year ago, massive Kelvin wave moved west to east. We thought this was the start of a major El Nino. Of course, it wasn't. There had actually been 2 smaller Kelvin waves prior to that in 2013. But no, then we had the upwelling phase of the Kelvin wave cycle, cooler temperatures, and now here we go, another small Kelvin wave in August, yet a broader, stronger one in October. Here is our upwelling phase we're currently in, and here's what we believe to be the next building Kelvin wave over in the West Pacific. And it's interesting, notice all this warm water way off to the west as compared to these previous Kelvin waves, and notice that this Kelvin wave started way in the west as well too. So it'll be interesting to see what happens with this one. You tend to get these big seismic sort of Kelvin wave activity in the January-February time frame. That's when, if you're going to have a major El Nino, you start seeing the early signals of it. If you're going to have a weak El Nino, you don't see signs of it until maybe the May or June time frame. That's why this one we thought was very significant, but it was interesting. Everything fell apart. We didn't get, basically, we're in ENSO neutral right now. No El Nino in flight, though temperatures are warmer. It's basically what we call a Modoki El Nino. Sort of an El Nino, but not really. That's what it looks like we're having right now. It's trying to be El Nino, but it is, at this point, it's too late. It isn't going to make it. If you're into, late January, almost February, and you haven't declared El Nino, you're not going to see it in March or April. That isn't going to happen. So what we're looking at is the development of more warm water pushing its way east for next fall. Okay, and when you get these Modoki El Ninos, sometimes they go for 2 or 3 or even 4 years in a row before they finally culminate in a big El Nino, and there's nothing wrong with that. It gets the momentum going, it gets the jet stream going, it gets the storm track, gets the machine basically primed, and so you not only get a better storm pattern in the winter, but sometimes it also works its way into the summer, and you go for a couple of years in a row. Certainly, we have been through a 4-year stretch of way less than normal storm activity, both in the north and southern hemisphere, so it's certainly time for a turnaround. Maybe this is it. And finally, the forecast from the CFS version 2, Nino 3.4 surface temperature anomalies. Now, it was showing anomalies up to 2 degrees above normal in October. It settled down. Again, this is suggesting a continuation of the Modoki El Nino scenario, 0.5 to 1 degree anomalies into next fall. Not bad, not great. Probably better than nothing. We'll take it. It still supports storm development. So for now, the pattern is continuation of Modoki El Nino, some support for storm development. Maybe the MJO will turn active, but basically more of the same. That's it for this week. See you again next week, same time, same channel.